Okay, then it's also for me to wish you all a good afternoon. And being one of the professors and researchers, I always have questions. So I actually would like to know if you could raise your hand online if you are having a lunch right now. So those who have a lunch, and also that you understand, if you understand research, which I think you will all do, is can you raise your online hand if you have a lunch right now? Well, that's not so many people, but a few lucky people among us. I think even Marcel is. So that's a good thing, and it will probably have an effect on our emotions in how we are listening here, whether we would have a lunch, yes or no. And that's the theme of today, among others. It's about experiences and emotions and how to measure them during the experience or in an experience or in a concept or in something that you believe and that they are important, we all know. I think we had one of the research that we did about virtual humans. We always ask ourselves, when is a virtual human realistically enough? And then we always measure that, for instance, by if the virtual human has the same capacity in evoking emotions, then we might have a realistically enough virtual human. And then to our surprise, of course, we asked people, how many emotions do you actually see when you talk to a person? And I don't know if you know still the percentage. I think we talked about it before, how many of the emotions you see in a face when you talk to somebody, but it was only 40%, which I think is very low. So that means every time you have a fight with your spouse or with your friends or with a mom or dad or any, then just remember they only saw 40% of your emotions. So that will save a lot of fights. But how important are they? What are they? How do you measure them? How do you measure them in the reality and in the virtual reality? That's something that we do at BUas in what we in our easy language call Experience Lab, but is a much bigger theme, which has started by Marcel in creating a huge lab and research theme to measure this. As well as to create and design concepts based on experience. So I'm really happy, Marcel, to give you the word about the work that we and that you do in on this topic and the insights that you have, or the questions that you have to the audience. So happy to listen to you now.
Well, thank you very much, Marnix. Actually, part of what I'm been presenting is stuff that I did together with Marnix, so he'll probably be familiar with most of the things I'm going to present. I just stopped having lunch because I had, although it's a lunch meeting, I thought combining having lunch and presenting is probably not the best idea. So let me share my screen and see if I can get your faces back in my window here after having done that. Yeah, there we are. So what I would like to talk about is experiences. What are experiences? Why are they important? What makes experiences valuable? What makes them memorable? How can we measure that? And so I hope to do that in the first 15 minutes, and then in the last 20 minutes of my contribution, explain or just present a number of projects that we did over the past years. That kind of make clear how we approach this empirically, so in actual research. Let's click on the right thing here. There we are. Just introducing myself first. I'm a bit of a strange guy to be working in leisure and tourism because I have a background in experimental psychology and in cognitive neuroscience. So the experimental psychologists are the kind of people that put other people in lab environments and then have them do all kinds of strange tasks and then try to figure out how thinking and feeling works in the brain. So I've been doing that for quite a while, then joined BUas, 10, 12 years ago, refocused my research on leisure and tourism. Got a full professorship in connection with Tilburg University, a couple of years ago. And so one of the things I'm happy that I've done in the past is that I set up and I'm directing our Experience Lab together with Marnix, with Monique Hover also. It's a joint professorship endeavor in that sense. Why focus on experiences? First, because as a psychologist, I think experiencing is really the essence of human nature, basically. And if we look at the knowledge domains that BUas wants to serve, leisure, tourism, hospitality, games, media, I mean, experiences are really the stuff that these activities or these knowledge domains are made of. If you are going to a theater or on holidays or out for dinner or playing a game, it's really the experience that you're after. It's not goods, it's not a service, it's really the experience that is of interest there. And also more broadly in other domains that are not perhaps logically associated immediately with experiences, such as logistics. I mean, how do you experience riding on a bike while you're being overtaken by a fat bike is very important in traffic safety, right? And so I can pull the same story for all the other knowledge domains that we're serving in BUas. So experiences are really an essential thing to study from a BUas perspective. And we want to do a couple of things in our research, design and development program on experiences. I think first and foremost, we want to help our industry be a better industry, right? So really move the industry field forward, help them to be more competitive, help them innovate. We want more broadly outside of the pure commercial industry, we want to help consumers make the right choices through experience design. How can you, let's say, nudge people into making more green, sustainable, smart choices, and more generally, how can you help people through experience design to live healthier and happier lives? And so I'm not much of a designer myself. I'm not very creative in that sense, but I'm a researcher and I always sit together with experienced designers, and very often people, especially in the industry, say, well, I know what my customers want. I don't need data because I've been in this business for 30 years and I have a gut feeling, and that works pretty well. And I always try to convince people that I really respect your knowledge and your experience and your gut feeling. But if, in addition to your gut feeling, you would bring a little data to the table, if you would make your experience designs just a bit more evidence-based, they will become even better. And sometimes it helps me convince people that experience research really helps make experience design better. So thinking a bit more about what are experiences actually? That's because everyone talks about experiences as everyone knows what it is. A couple of years ago, we presented this model, and it landed pretty well within academia and also pretty well within the industry. I'm not going to explain all the dirty details of that model. It's a cognitive psychology model of how experiencing as a process takes place. And I think what's important there is that in this model, emotions play a key role because we believe that emotions are key in making things that you experience, which may be very normal things, such as biking to work or having breakfast with your kids. But sometimes emotions get involved, and these emotions make experiences valuable, make them memorable, perhaps even meaningful and transformative. So emotions are key in understanding the notion of a memorable experience. What's also important to realize, and people often forget that, especially if you do research based on traditional research methods with surveys and with interviews, you typically intercept people after the experience took place. And then you think of an experience as being a thing that happened at one moment in time, but actually an experience is something that takes place in time. It's an episode in our time. It's an experiential episode with a clear beginning and a clear end most of the time. Right? This is an experience. And if you would plot emotions on the y-axis of this graph here, then you'll probably see that emotions are coming and going during a particular episode, and are waxing and waning, and the exact pattern and the level of emotional engagement during a particular time interval or episode determines whether or not you will remember the experience in the first place. If there's no emotions involved at all, we know from cognitive psychology, then experiences are not stored into memory, they will not be remembered. So the first precondition for an experience to be memorable is first that it has to be remembered. Yeah? And we need emotions for that. If you consider the timeline a bit further, zooming out a bit on the timeline, an emotion takes place at some point, and you could call that the lived experience, while it actually takes place. And after the experience is over, you will start to remember it, right? So an experience cannot be memorable right after it ended because some time needs to develop, needs to evolve for it to become memorable or not, right? So what needs to happen is that there needs to be a process of remembering. And if that remembering is about the strong emotions that you had during the experience, then the experience is said to be memorable. So emotions are key first in making sure that an experience is remembered at all. And second, after the experience has passed, emotions are crucial in making an experience memorable. So if you would want to go along with me on that, then I think you'll see that it's important to try to measure emotions while the experience is actually happening, right? So in real time. And that makes it difficult to use traditional research methodology because if I'm an interviewer, I can sit next to you while you're in a roller coaster. But if I ask you every 5 seconds, how do you feel now? How do you feel now? That's going to completely destroy the experience itself. Same with surveying, right? So we have to go to different toolbox of research methods for being able to track emotions as the experience is unfolding. Given that I have a background in psychology and in neuroscience, this is the toolbox that I've been developing together with my colleagues here that try to do that. So, what's that? This is just showing part of the research group that's involved in running the Experience Lab at BUas. You see that we're all a happy bunch. We even have a t-shirt that makes us feel that we're part of a group. So that already helps. And what we do is, so we have a range of tools that we can use to measure emotions during lived experience. And we started out in a lab environment. The problem with the lab is that there's not much experiencing going on. But in the lab, we can record brain activity. You see this cap that the person has on with electrodes sitting on it. That allows us to record electrical activity coming from the brain and to relate that to what people are experiencing. You can also see that this person has wires going here that will monitor heart rate, wires connected to the fingers that are monitoring skin conductance. I'll get back to that in more detail later. And we can measure what people are looking at through an eye tracker. So these are the tools that we have available in the lab to measure what people are experiencing. The problem with a lab setting is that there's not much experiencing going on in the lab itself. So we can bring experiences in the lab through virtual reality or augmented reality, or to a television screen or to audio input. So that works to some extent, but it also has limitations. So what we've been working on pretty strongly over the past 5-6 years is to develop research methods and use wearable research devices that allow us to measure more or less the same things, but then out in the field where these experiences and the leisure and tourism hospitality experiences are actually happening. So we have a number of devices. What you see here is this black wristband. It's an Empatica wristband. We've replaced it by its successor, which are shimmer devices. They do exactly the same thing. They're connected to electrodes that are placed on the finger that allow us to monitor heart rate and skin conductance, which, as I will explain to you in more detail in a minute, are both indications of emotional arousal. We can also measure GPS because people give people a phone or a GPS tracker and record where they are going. and you can measure where they are, right? So where they are feeling these emotions. And we can also, we have these glasses that you see on the bottom right of the slide, are mobile eye trackers. So there's a lot of little cameras hidden in there that record the head view of the camera, so what you're looking at basically, but also track specifically what you're fixating on, right? So we can measure what you feel, where you feel it, and what you're paying attention to. Right? While you're just freely moving around in out there in space. So we have a pretty good grasp on what you're experiencing when we combine all these research methodologies. We use skin conductance quite a lot in many of our projects. So let me just expand a little bit on what skin conductance does and why it's such a nice tool to use. And I have this very simplistic animation. Sorry for that, but I hope it makes it clear what skin conductance does. Basically, it all starts with you sensing an emotion, feeling an emotion. So your brain detects that. The emotion leads to a certain pattern of brain activation. And what the brain will do, it will trigger the peripheral nervous system, and it will activate the sweat glands that you are having, and that mostly sit on the palms of your hands and the soles of your feet. And these sweat glands are then activated, and what they do is they secrete sweat. So it's not that you're immediately going into heavy sweating, but there are very slight, small, most of the time almost unnoticeable differences in sweat secretion as a function of you feeling an emotion. Now, so your hands and your feet will become slightly wetter. You don't feel it, but it's measurable. And as you probably all know, that water is a good electrical conductor. What you could do is to put a small current on two electrodes, such that there's a small polarity difference on two electrodes, such that a small electrical current will run there. Very small, you don't feel it as a participant. It's really, you don't even notice that. But if the hands and the feet become wetter, more current passes between these electrodes. Right? So if you now measure this continuously, then you have this continuous measure of skin conductivity or skin conductance, electrical conductance, is a real-time measure with millisecond precision of emotional engagement. Very simple, very effective. That is laying out, let's say, the theoretical considerations for us to focus on emotions and the measurement side of it. I'll now turn to just presenting 3 different projects to you that we've been using in the past. We've run, I think, in a total of more than 60 projects over the last 6-7 years in the Experience Lab. I'd selected a couple that in which we used virtual reality because that connects well to the digital realities theme. But it's just a small selection of the stuff that we're doing. So one is actually set in a theme park setting. And there you have this theme park in the south of Germany, Europa Park. And they used to have this bit of an old-fashioned roller coaster, the Anzian Alpen Express. It was an old roller coaster, not very exciting. It was a bit at the end of its life cycle. And the park managers were having to decide, are we going to replace this roller coaster and invest another 10 million in a new roller coaster? Or perhaps what we could do is to create a virtual reality add-on to this coaster that would extend the life cycle of it. So there are 2 ways in which you can ride this roller coaster. One, normally, then it's a relatively low excitement roller coaster ride, or you can put on a VR headset and then you're immersed into this computer-generated environment. An example that we have been using in research, you're virtually flying in a plane, and the movements that this plane is making are perfectly synchronized with the actual movements of the roller coaster. So you really are totally immersed into this plane environment. Now, a typical research paradigm to see if this is effectively extending the life cycle of the roller coaster would be to ask people at the end of the ride, after the ride has ended, how positive or negative did you feel during the ride? That's valence, and then you see the red The red bar on the left hand is showing that people feel very positive when riding this roller coaster with VR, and more positive than when you ride the roller coaster without VR. That's the blue bar on the left. And if you ask people how excited did you feel that the ride was, then you see that adding the VR environment makes the roller coaster much more exciting. Right? It's all measured on a 5-point scale. So if you look at arousal before, so without the VR headset, it's a 2 almost, so not very exciting. And with VR, it's a 4, pretty exciting. So this effectively shows that using the VR headsets and the VR environment makes the roller coaster more exciting, right? But it doesn't really inform the designers of the VR experience what worked well and what didn't work so well. So what we did in addition to this is to have people wear these wristbands and measure skin conductance as they were riding the roller coaster. So what you're now seeing here is a bit of a complex graph, but it is on the x-axis you have 100 seconds. That's the time of the roller coaster, 1 minute 40 seconds. And on the y-axis you have a measure of skin conductance, so the measure of emotional excitement, as you wish. And the red line gives the average skin conductance of 35 people riding the roller coaster with VR. Sorry. And the blue line gives the average skin conductance of 35 people riding the roller coaster without VR. Now what you see here is that there are clear peaks and troughs in the excitement over the ride that are pretty consistent also across the two groups. So the initial accelerations are exciting no matter whether you wear a VR headset or not. The end of the ride is very exciting no matter whether you wear a VR headset or not, but there are also differences. So at the very beginning of the ride, so even before the ride has started, it's much more exciting to be in this virtual environment than to just sit in the coaster waiting for it to start. You also see that the excitement is just a bit larger during the accelerations, probably because you don't know where you're going or this plane is really taking off there. And what you also see is during the middle of the ride, there's much more excitement in the red line. So the red line goes much higher. So in the VR group than in the no VR group. And what's happening there is that in the virtual reality ride, there's a looping. So you think you are in a looping, you really feel that there's a looping in the roller coaster. But then if you ride it again without the VR headset, you realize that there's no looping at all. It's really a virtual looping, but the VR environment is really good in tricking you into thinking that's a real looping. And you see the long-lasting effect that has on the excitement that people feel during the ride. So what we see here is that you have very fine-grained temporal information of where the excitement takes place and where it doesn't. And so everything between seconds 60 and 90 is not very exciting. So if you would want to make the coaster a bit more exciting, you would want to add more VR excitement there. And so based on these time-resolved measurements of emotional excitement, we can really inform the experience designers of what worked well and what didn't work so well, right? So that they can use that information to improve their experience design. I think that's really added value compared to just asking people how excited did you find the ride. Second example is happens to also take place in a theme park setting. That's a bit of a coincidence. This is a study that we did with the Efteling, and you have the Dream Flight and the Droomvlucht. I don't know if you're familiar with that. That's a fairy tale environment. So what you are doing as a visitor to that attraction, you sit in the gondola, and then you go through these beautiful fairy tale themed environments, which is a very immersive and exciting ride. It's also a bit exclusive because if you have a physical handicap, you cannot sit in the gondola. So what the Efteling did is to create a virtual reality version of this, so that people with physical disabilities can also ride this attraction. And even better, if you are visiting the Efteling with someone who does not have physical disabilities, then you can split up And part of the party can sit in the gondola and the other can do the VR ride, and you are connected through audio to each other so that you both experience the same environment, but you can also communicate. And you have social interaction. So basically that creates three different types of rides. That's how we approached it in an almost experimental design, where there's a real life physical ride that you can do. You can do the VR ride with social interaction, and you can do the same VR ride without social interaction. So we can kind of see how similar is the VR ride to the real ride, and what's the effect of social interaction in creating that similarity. Now, if we base ourselves on self, so after the ride, we ask people, can you give a grade to this ride? Then the physical ride gets a 9, and the VR rides get about an 8. And you see similar patterns occurring when asking for the intent to recommend and the intent to revisit the ride. So the physical ride is always better than the virtual one, but it seems to be that adding social interaction to the virtual reality environment makes it just a little bit better. Now, if we look at the emotion profiles over time during the ride, so same setup. So time is sitting on the x-axis here, emotional excitement or engagement sitting on the y-axis again. So higher graph means more excitement. And then we have three groups now. So the red line is for the physical ride, the real normal ride in the gondola. The blue line is for the VR with social interaction, and the green line is for the VR without social interaction. So what you see is that there's a lot of excitement going on in the beginning for the physical ride, and there are moments in time towards the end of the ride. There are three big peaks that you see here where the ride is most exciting. If you look at the blue line, that kind of follows the same pattern, but with less intensity. There's this bump at the beginning, there's these three bumps at the end. So qualitatively, there seems to be the same pattern of emotional engagement over time, but just a bit less intense. Now, what happens if you take out the social interaction so that people can't share the experience with the others? Then you see actually a different pattern of results. You don't see the bumps at the end. You see a very strong increase at the end. We can't really explain that, but you see that there's not only quantitative intensity differences there, but also qualitative differences in how the ride is experienced in the different sections. Now, putting these two studies together, what can we say about it? Well, we can say that in both cases, stronger emotions correlate with more positive evaluations. So really driving home the point that emotions are crucial in making experiences valuable and memorable. And in the last study, I think we very nicely show that in VR experiences, social interaction is really missing. And if you would add that, then it makes the experience more real-like. And I hope I've convinced you with both studies that if we have these time-resolved emotion measures, we have a much better common ground to talk to experienced designers and to inform them about what works well and what doesn't work so very well in the experience design. Okay, so the last study that I would like to share with you is a study that's in preparation. It's a study that has been designed and performed by Saeed Durgun, who's a PhD student in my lab. And he has used EEG, so brain recordings, to study the restorative effects of VR tourism experiences. Now, it's a bit of a more complex story, so I'll try to guide you through it step by step, and I hope that I don't lose you in the process. So let's first start by talking a little bit about EEG. So EEG is recording the electrical activity of the brain. So now this is a visualization of brain cells. You see sometimes they fire, and that firing means an electrical burst that are then sent along to other brain cells. That's a way of the brain to communicate internally. And so you can record this electrical activity of the brain from the outside by putting a cap on people with electrodes. And if you properly amplify the signal, you capture microvolts, that's a millionth of voltage changes. You have to amplify that, and then what you see on the scalp in the recordings is basically you see oscillations, you see rhythms in the brain. And depending on the frequency of that rhythm, it goes together with particular functions. So very slow frequencies, delta frequencies, that are running less than 4 cycles per second are associated with deep sleep. And then all the way up to the very fast rhythms that we have in the brain, gamma rhythms, which run like 30 to 50 cycles per second, are associated with complex cognitive processes and anything in between. Now, for this particular study, we were interested in 2 particular rhythms. So the alpha rhythm, which is an index of relaxation, because that's mostly seen during relaxed wakefulness, and beta rhythm, which is related to active thinking and paying attention and being alert. Okay, so alpha for relaxation, beta for being alert. So this is what these things look like in real recordings. And so what you can see as an analogy is that the room with people sitting there is the brain, and the EEG device is basically trying to listen into the room to see what's happening there. And if it's relatively quiet in the room, then what you'll see in the EEG is alpha oscillations. And if it is very busy in the room, and you listen to that through EEG, then you'll find beta oscillations. By the way, these slides have all been made by Said, so full credits to him for all the visualizations and everything. Okay, so the study itself was about VR tourism, and that is not going on holidays virtually for 2 weeks in a row, but that is seeing whether short, a few minute VR experiences would allow you, even during a workday, to disconnect from work, to relax, and to mentally recover. So this is Said preparing an EEG participant. This is our EEG setup, the EEG cabin in which participants are placed in our experience lab. And this is what Moji, one of our researchers in the lab, looks like when he's about to start the experiment. A bit anxious, but he'll be relaxed pretty soon. So we ran an experiment with 3 conditions. So one condition in which, so in all conditions, people saw a 3-minute VR video. And that's our VR tourism manipulation. And in one condition, there was a very relaxing environment. It's just a natural landscape intended to induce relaxation. In the second condition, in an adventure tourism condition, it was a jump out of a plane in a wingsuit. Pretty exciting. You'll see it in a moment. High speed, high adrenaline, adventure tourism experience. And we had a control condition, which is just our boring campus in a 360 environment for 3 minutes. That's the neutral, emotionally neutral control condition. So we had 3 groups. So either you saw the relaxing video or the adventure video or the control video in VR. And before and after, we had people self-report on their psychological detachment from work and on their relaxation. Okay, so these are the self-report measures that we take. And what we expect is that these relaxing VR videos induce relaxation, and that these adventure VR videos induce psychological detachment, because you don't relax during those videos, but you are so immersed in that experience that it really detaches you from your here and now and from your work day, basically. And together, relaxation and psychological detachment from work psychology theory both have restorative properties. That's the idea behind it. If we look at the self-report data for the 3 groups, the pre-test, so before the experiment starts, is the yellow, the orange bar, and the blue bar is after when people come out of the VR experience. What we see is the relaxing VR experience. That's the left-hand bars. So relaxing VR videos make you relax. Adventure VR videos also make you relax, but a little less. And the control video doesn't make you relax at all. If you look at psychological detachment, you see a reversal there in the two experimental groups. So the adventure videos are better in creating psychological detachment, and the relaxing videos are better in creating relaxation. So it does what we intend to do if we go on the self-report data. Now, if we then look at the EEG data, and this is our way to represent the EEG data, it's a bit of a funny way, but it works well for the present purpose. Again, you have time on the x-axis, so 180 seconds, the 3 minutes. And on the y-axis here, you have the frequency of these rhythms. And the alpha rhythm is around 10 hertz, and the beta rhythm is a broader range around 20 hertz. Right? So these are the things that you should focus on in the subsequent graphs. Now, if we look at the relaxing, so this is actually the data from the relaxing group, and what we see there is all the way almost from the start. So starting as early as 10 or 20 seconds into the video, you already see that the alpha rhythm is getting stronger, and it's getting stronger mostly on the central parts of the scalp. And that is really a reflection of the neural process of relaxation. And we don't see anything happening in the beta frequencies and in the beta rhythm. Now, if we skip over this one, this is the same representation of EEG data, but now for the adventure group. And what we see here is nothing is really happening in this alpha rhythm, but there's a very strong increase in this beta rhythm and even beyond in gamma rhythms during the watching of this adventure video. And it sits mostly on the back of the scalp, so it's really a different effect. And it's funny if you look at the time course of it. That's on my next slide. So you can compare the time course with the cursor here. You see that people jump out of the jumpsuit, jumps out. It gets pretty close to the rocks here. So a lot of excitement. There's a little peak here, a bit of relaxation. Then another peak excitement here that you see very well reflected in the EEG. And then things ease up a bit more, right? So a bit less exciting. So the time course in the EEG corresponds pretty well to what you see happening in the video, actually. Yeah? So here things are more relaxing. You just float in the air, nothing exciting happening. And then when you get closer to the landing moment, then you see the excitement also in the EEG getting up again. I think the correspondence is really striking here. And what we see in the control, this very boring office environment, is nothing much happening. But as we are sitting longer and longer in this boring environment, you see the alpha rhythm coming up again here. So that's just reflection of relaxation, but now not through something nice, but actually through boring you out, basically. Okay, so pretty different patterns for the 3 different conditions and really along the ways in which we hypothesized. So to wrap up that particular study, I think that we quite convincingly show that even a 3-minute VR tourism experience is long enough to induce the well-known restorative effects of relaxation and psychological detachment, as evidenced through the self-reports. We see that relaxing VR tourism experiences mainly induce relaxation, adventure VR tourism experiences mainly induce psychological detachment. We see that reflected in different brain dynamics. So we really have the biological basis for this to convince a critical audience. And to wrap up the overall story, so zooming out a bit now, I think it's good to realize that emotions are crucial building blocks of experiences, that measuring the emotions during experiences as they unfold can be done with psychophysiological tools like skin conductance, neuroscience tools like EEG. We can do that both in the lab and in the field. And I think that this quantitative measurement is really a promising avenue to studying different types of experiences. both scientifically, because there's not that much academic work done, but also from an applied perspective, because we can really help people to make better experience designs. And that ends my story.
Well, a big applause first, online or in real. I don't know which causes more emotions, Marcel, if it's real applause via audio or visual applause, but maybe we can measure that.
It all adds up together. Thanks.
I mean, thank you so much for explaining, I think, in very understandable examples and language in what is a very complex construct in our bodies, even though we talk about it if it's very easy. I think we get a lot of insights, but maybe also a lot of questions, of course. So I would like to start with, of course, the audience, and maybe if somebody has already a question on the outcomes, on the measurements, on the implications, or on ideas, or on similar research or findings, then you can either raise your hand, and if you don't know how to raise your hand, then just scream. Does somebody already have a question right now? I always have to check in Zoom. Yeah. I see Atanasova. Victoria, do you want to start?
Yes, hi. I wanted to thank you first, Marcel, for this wonderful presentation. I'm actually a master's student at BUas doing a study also on measuring experiences. And I wanted to ask you if you found what is the best sort of time in between the experience and measuring the experience, in your opinion, because you mentioned that you don't want to measure it immediately. You want to let the person kind of process it a little bit more.
No, that's a good question. I think I mean the tools we've been developing in the lab are mainly meant to measure the experience in an unobtrusive way as it is unfolding, so that you have a real-time view on the emotional engagement during the experience. Now, with more traditional research methods, that's more difficult, because then if you ask people all the time, you can do it with an interview or with experience sampling methodology, or then you're disrupting the experience. So the second best thing you can do is to take people immediately after the experience ended and ask them or try to make them reconstruct the experience as it was unfolding. My former PhD student Wim Strijbels has studies in which he uses this experience reconstruction methodology. But I think if you can't measure something during the experience itself, then your second best goal is to be as short on the experience as possible. Right? So as soon as possible after it ended, because otherwise, the longer you wait, the more memory distortions you will get in any record of experience.
But that would always be in a quantitative approach, I imagine, similar to your research.
Yeah, so if you want to measure real-time emotions, then you have to rely on quantitative measurements. Yeah.
Yeah. Okay. Thank you so much.
Did that answer your questions? Although, of course, you can use it. What we do often also with eye tracking or brain scan is when you do interviews, you can, because the data often is very fast to apply, to get or to visualize. We often use it as extra input for qualitative research. So if we do interviews, we sometimes take the eye tracking data to better understand what happened during an experience. So it also gives you extra data for qualitative research. But your question is different, of course, then. It's not about what happened, but it's more to have data to understand why it happened.
But then I imagine that the collection of the quantitative data precedes the interviews. Then you would take that to the participant, for example, and say, "Oh, in this moment, something happened. Why?"
Yeah, for instance, so you want to know, like, okay, does it confer with the design that? So it's more about indeed the why questions.
Yeah, and it's also, if I may jump in, there's also it's good to realize that, especially in skin conductance, you can measure emotional excitement, right? Arousal. But what you cannot measure is whether this is due to positive emotions, positive feelings, or negative emotions, right? The signal cannot differentiate between that. So what we do often is to sit with participants after the experience ended and collect qualitative data on what exactly. So we see a peak there. What did you feel there? Was it something positive or was it something predominantly negative? So these qualitative data can help give the right color to the quantitative data that we collect.
Yeah, thank you so much for this perspective.
Thank you for your question. Is there another question that you would like to ask to Marcel?
There's one in the chat, Marnix. Shall I
Yeah.
read it?
Yep.
So you mentioned that some parts of the experience are boring, and in the case of a theme park, you mentioned that they could up the arousal in VR experiences when people showed less arousal. I'm wondering whether it might actually be good to have differences in arousal, leaving very small amounts of time for the brain to deal with the experience. Yeah, that's a very good point indeed. In a study that didn't present, but that we ran a couple of years ago, we've compared a situation and there was high emotional arousal all along the experience versus an experience design in which there were peaks in arousal followed by troughs of relaxation followed by peaks again. So really a waxing and waning. And what we showed there is that the peaks and troughs experience design led to a much better experience for people than the peaks only design, right? So we published a paper about that with the title "More is not always better." So it's indeed the case that the best experience designs seem to come from moments of excitation followed by moments of relaxation, so that people have the time to process what just happened and be prepared for the next peak, actually.
And I think that also follows up with what a lot of the designers use, right? They use those emotional constructs to design a route in an amusement park or something.
Yeah, absolutely. So designers use that very intuitively. Huh? So again, most of these intuitions are good to have, but if you can really show that that's the case with actual data, you can also see what the specific flaws in the design are.
Yeah. Yeah, it was super interesting. Is there another question from the audience? Thank you, Marielle. Right now, or while you're thinking. So while people are thinking, Marcel, there's also always the question, like, what is for you really the next thing to measure? What do you really want to know still? What would be your ideal next project?
Good question. I think we've run, you and I together also, quite some projects where we use VR experiences. We've run a few projects now with augmented reality, which has the big advantage that you don't displace a person into another reality, but you just add on top of the physical reality. These are difficult experience designs to make because there's a lot of technical stuff going on there. I would really want to develop that further in the future. And then play around with different types of additions onto the real reality with this augmented reality to see which design principles we can derive from that.
To enrich our real experience.
Exactly, and not just taking people out of the here and now, because that's the big drawback of VR in the end. Yeah.
Is there anybody in the audience that has used before this type of research? Or is it all new for you? Or do you have a case for those which you would be like, I see that one, Mavridou, do you want to elaborate on that? And if you have the same type of findings so far, or the same way that you used it?
Hi. Yes.
Hello.
There are some similarities in some of the work that we have been doing. I'm in the virtual reality lab in Mind Labs at the Tilburg University, and there's a lot of nuances in the way that physiological signals and some of the patterns can be used to infer affective states, emotional states. So it's a very, very interesting area, and thank you very much for the presentation. I wanted to mention from my empirical knowledge, there are some delays inherent to the detection of peaks, let's say, in the physiology, especially when it comes to the conductance levels, right? So it is quite hard to directly link to important events that are happening within an experience. And of course, when we're doing this sort of analysis, we can take longer events. I don't know what your recommendation would be with that. But the latest example, for example, we work with Perl. I don't know if you are aware, this virtual reality sort of experience that's meant to be anecdotally very emotional. So we wanted to see with the physiological signals whether we can detect that. And we found that there was this inherent delay from the expected intent of the creator to induce this emotional activation to the point where we detected it. So I just wanted to bring this up and make a discussion about it.
Yeah, that's a good point indeed. With the risk of becoming a bit too technical, but there are two types of delays, right? One delay is from the stimulus in the environment to actually sensing the emotion. And the other delay is from sensing the emotion to measuring something in the periphery, especially with skin conductance. So with respect to the latter delay, I think we have a pretty good grasp on that analytically by using, by splitting the signal in phasic and tonic components and then applying deconvolution to the phasic component. I think you can pretty much get back to the phasic driver. So actually the moment in time that the physiological response has been driven, has been triggered, basically. But psychologically speaking, the most interesting delay, of course, is between how you stimulate the environment. So the stimulus that happens in the environment, and from that to when you actually sense an emotion, because that's also pretty variable. That varies a couple of 100 milliseconds from one individual to the next, and from one emotion to the next. So there's a jitter there that's much more difficult to control. I hope that addresses the question that you had about it.
Because how did you solve it, Virginia? Did you just did you take that delay into account in your analysis, or did you just not use it, the data?
We used a similar approach, so we sort of took larger time windows, again allowing for that additional millisecond delay to take place, because exactly like it was mentioned, it could be dependent on the individual, but it's in milliseconds as well, or we might see a larger peak later on, which is accumulative over time. But with the analytical approaches that we take so far, we can trace it back. But yeah, it's a recurring issue. I suppose we're trying to really tackle which of the events actually triggered this response if you have too many one after the other, especially in a very dynamic experience like in virtual reality.
Yeah, it's the challenge of porting things that have been very clearly demonstrated in isolated lab conditions, where you are isolated from the environment, you get one stimulus, you can see what the response is to that, right? That works pretty well. And then transposing those methods and findings to a real life environment. I mean, that's the big challenge that we face if you want to study real experiences.
Yeah. I remember that we had that problem in the games, because in game designers are the optimal persuasion people to make a balance between frustration and reward, right? So you give a reward to going to next levels or in play, and then if the frustration becomes too high, you want to make the design simpler and give them a reward. But to do that on that small level of jumping around and everything, that was just too much of a delay that we couldn't see which factors influence that. So then it becomes too problematic. But it gave us a very good design on the overall gameplay and scenes and when to break scenes and not. So that helped. But for the internal gameplay, it was too difficult. Yep. So that's also the point, of course, is like, what does it gain and what does it not gain? Is there another question for Marcel on the impact or on the... already raised your hand, so the floor is yours, Gigi. But you are muted, which makes it very difficult for Marcel to answer, probably.
I'm afraid we still can't hear you.
I clearly see a disappointed emotion right now, even without brain scans. Do you want to try it on the chat, to put it on the chat? And then we wait for that, and then I'll just have one in between that we wait for your final question. It's more like an existential question, maybe, Marcel. But so if you can see that VR is able to create the same emotions and sometimes even higher emotions. So from an emotional point of view, is it very common that we will live in a virtual reality in the future?
I'm not sure how much research findings we have on that. I think this dream flight example is one of the rare situations where we can really compare a real life physical experience to a VR experience, because they're really shaped very similarly. And there what we see is that qualitatively the pattern of emotional arousal over time is the same for both experiences, but more intense in the physical way, in the real life experience. So you can approach reality with VR, but you cannot replace it. But this is this one study, and I'm not aware of studies that have well that match this, really paralleling the real experience with the virtual experience. If there are any, please let me know, because that would be very informative. But this is still pretty much an open question to me.
Yeah, would be very interesting, because we have a lot of people that still live, for instance, 30 years already in Second Life in the virtual environment. If they and they get married and they have kids with each other, and to see if those emotions are the same as in the real life. Gigi, did you manage for the final question?
I hope. Can you hear?
Yeah,
can you hear?
We can.
Okay, perfect. Yeah, thank you, Marcel and Manix. And I'm Marcel. I am very interested in the first example you mentioned, because when you measure the emotions with this helicopter layers, I saw there's a little part that there's a fish. Yeah,
True, yeah.
that related to that you mentioned. There's an augmented reality. I'm curious. Is that means that you add fish in the virtual reality to let the participants see that?
Yeah. So what was there in the virtual reality ride? This virtual roller coaster ride. Is that so people were flying in a plane, and then they had this looping, and after the looping ended, they would fly over a big lake, and at some point a really huge fish would jump out of the water and fall back into it, all virtually. That's also all in VR, basically. Yeah.
And is that and a special design for purpose, or?
Yeah, that was designed as a triggering moment to induce emotions there. And you see that back in the skin conductance response. So you see another bump there, which is probably being triggered by this event, indeed. Yeah.
Okay. So do you think that this can be regarded as evidence that when people see animals, something related to nature that can help them to connect with the feeling towards the nature.
I'm not sure if the conclusion can be that specific. I think
it does not need to be conclusion, but kind of idea, inspiration.
It shows that if you have a surprising event, it triggers an emotion. But if you would want to see whether that is nature specific, you would need to contrast it with a condition in which you have something not nature specific. Right?
No, I understand that. Yeah, because that event alone that cannot just be concluded with that. Yeah, I'm asking this question because in my research that I'm often interested how these people can be triggered by the connections with nature. And there's argument that augmented reality and virtual reality can contribute to this kind of feeling. Yeah, but it's also very difficult to measure. Yeah, so that is more like and more wild questions seen together from your experience.
Yeah, I think we have the measurement tools. So then the question is, can we design a good AR contents to do the experiment, basically?
Yeah. And how we are sure about that is connected. Okay.
Okay, thank you so much. And it's another good invitation, I think, for Marcel to collaborate, which we want to do, of course, with these lunch meetings. It's not an ending. It's just to share insights and to invite you to collaborate within the DIGIREAL theme or in the consortium of Mind Labs or in the crossover with the other themes. I know there were some other questions in the chat. And again, this is an invite just to keep in contact, which is always possible. I also want to mention that on the 6th of February, there's a new lunch meeting. So that's already 2,025 people about emotional interactions with virtual humans. You can see the invite in the chat. And then I think we just can give a big thank you again for Marcel for the presentation, the insights. And I know he's really keen on collaborations and sharing ideas. And I think so for a final hand and clap and thank you, I can be the first maybe to wish you all a good 2025 and a big Christmas from Mind Labs and the whole people and the bunch of people behind it. So thank you very much and hope to see you at least next year on the next meeting. And Marcel, again, many thanks.
Thanks, my pleasure.
Thank you.